It's a pleasure to be with you today. We have an exciting topic, but I will lead with some very important information. There's a specific reason why this presentation is called Surviving Survivability. This is a very difficult topic, and we will do our very best to cover it thoroughly in the next hour. But I have way too much information in this presentation, so at times I'm going to go rather quickly. I will be providing a handout PDF to Anne-Marie, and if you would like a copy of that, you can contact her after this presentation, and she can get that to you. And that might be helpful because there's a lot of information to digest. So again, we today are going to be talking about surviving survivability, and we try to make this a user's guide to make it as helpful as possible. We're going to cover four major sections. We're going to look at the code history of circuit survivability. We're going to go through that as quickly as we can because there's a lot of history there to describe, and we could go on for a long time. We're also going to talk about product listings and how the UL product listing has an effect on survivable cable and how you can better understand that. Then we're going to specifically look at what fire alarm circuits must be survivable and how you can accomplish that. And then we'll finish with some good reminders and tips on how a designer can provide and an AHJ can approve a survivable cable installation, because these are fairly unique. First, I'll start with a disclaimer. I do sit on the NFPA 72 ECS committee, in which survivability is a lot of work is done on that committee, but I do not represent NFPA. We encourage you certainly to buy NFPA 72, and that reflects the official position of the National Fire Protection Association. Additionally, we'll be showing you some information on Underwriters Laboratory, and that information, they also trademark their information. So just a brief legal disclaimer. What is pathway survivability? Well, first and foremost, it's a defined term in NFPA 72, and it's the ability of any conductor, optic fiber, radio carrier, or other means for transmitting system information to remain operational during fire conditions. So that's actually exposed to heat, flame conditions that most wiring would be destroyed when subjected to those kinds of temperatures and those kinds of conditions. So when we talk about pathway survivability in the code, that's exactly what we mean. We are actually exposing this wiring to flame conditions or fire conditions. Let's start with the code history of circuit survivability. A lot of folks, we do this because a lot of folks think survivability is a fairly new thing. In fact, many would guess that it started in 2010 with the newer edition of NFPA 72. But when we actually look, it's not new. It traces all the way back to the 80s, some 35 years ago, to a document called NFPA 72F, back when we had the pamphlet forms of NFPA 72, way before we had the National Fire Alarm Code as we know it today. This is what that looked like, and it talked about survivability. And again, it talked about attack by fire, causing failure of equipment. We didn't want to compromise from one zone to the other. And that same principle is really in the code today. In fact, all of these exceptions that you see there in one form or the other are actually existing in the code today, although a lot of the verbiage has changed. Well, when we got to the first edition of NFPA 72 was 1993, and that's when they combined NFPA 71, 72, and all of these pamphlets into one united code. This is what the code looked like from a survivability standpoint back in 1993. It was in Chapter 3 of that book, and in this, we see the beginning of a lot of the same principles that were carried over from the earlier document and that we still see in the code today. It talks about the loss in one evacuation zone not hindering another zone. It talks about 2-hour rated enclosures, 2-hour rated stairwells, fully sprinklered, not applicable to general alarm. All of these things that we see in some form today. Now, way back then, this seemed to apply only to quote unquote communications paths or circuits. And that was up to some interpretation. It wasn't actually defined what kind of communications we were talking about. The 1996 edition of 72 was the first to incorporate additional specific protection requirements for circuits from attack from fire. First, we had section 3-2.4. It was almost completely unchanged from the 93, except it added some very important words. In exception number 4, it added this 2-hour rated cable assembly. And that becomes very important in what we're going to talk about today. This also still seems to only apply to voice communication circuits, so there's still some ambiguity about what we're talking about. Then another section was added that circuits, to say additional circuits needed protection, specifically a connection between a fire command center and central control equipment, and it stipulated 2 options. We'll see how these 2 requirements kind of change over time. In the 99 edition, it followed the same basic concept, except now it permits 3 options for circuit protection. You see it at the bottom of the screen, using a cable assembly, a shaft, or a stairwell. The stairwell in a sprinklered building is interesting because this is the last time we see an allowance of allowing fire alarm cabling for the building to be routed in a 2-hour rated stairwell. That's certainly not allowed. But what's interesting is if you had buildings that were built to the 99 or previous editions of NFPA 72, those buildings are probably ready for a remodel or a renovation. And you might find a lot of the wiring for the fire alarm system in stairwells because of this exception or this method that was allowed. But it certainly goes away in the very next edition. This also changed to make, notice it's completely using the term notification appliance circuit. So that's kind of in our normal genre now, rather than just talking about communication circuits. This was important because in 1996, we had the ADA rules that were passed, and it became law that visual circuits and audible circuits need to have the same protection or be valued in the same way. Now, the language about fire command centers, that continued, and again, we'll see how that morphs over time as well. In the 2002 edition, they moved all the requirements from Section 3 to the voice section of Section 6. And it changed this 3rd option. So it removed, you can't put it in the stairway anymore, but it now allowed you to do a performance alternative that's approved by the HJ, and that remains to this day. And they did add clarification specifically saying it does apply to audible, meaning tone or voice circuits, and visible notification appliance circuits. So again, making that very clear. The Fire Command Center requirement came through as well. It reads a little different, but these 2 are starting to come closer together. But they did add this curious exception about a fully sprinklered building, and that still we still see those kinds of requirements today that are in the code. In the 2007 edition, it kept the requirements in the EVAC section, which was 6.9 at the time. The relocation requirement is still there, so but it puts it into more building code language. So rather than, we speak of general alarm, but systems using relocation or partial evacuation, which are really building code terms, very specific that applies to survivability even again to this day. Suddenly, instead of our 2 options and a performance alternative, we have it expanded out to these 5 options. And we also see for the very first time reference to circuit integrity cable or CI cable. This is the first reference in NFPA 72 to that term, and it's a term we use today. It does refer to survivable circuits or cables. And then we see it separate from a cable system. And we'll talk about what an electrical circuit protective system is in just a little bit. And you see now we've got this 5th method where if you had an automatic, if you have a fully sprinkler building and metal raceway, that is a method to provide survivability. And we'll see how that changed as well. The The fire command center separation language basically goes away, but they changed it to say when you've got an emergency voice alarm system, which is our EVAC system, and you've got remote equipment, where one piece of equipment is dependent on another piece of equipment, then you have to provide the survivability. And we see that in our larger buildings, either through the use of transponders or through the use of networking, where one panel may be dependent on the other. We see this dependency that's created. And then for the first time in the 2007 edition, it added requirements for firefighter telephone systems to be survivable. So that came in the 2007. So now we have three major groups of survivability requirements: notification appliance circuits, dependent control equipment, and firefighter telephone. Now, 2010 was obviously a very significant change to the code. We had a new title, we had a new format, we have two brand new chapters, Chapter 12 on circuits and pathways and Chapter 24 for emergency communication systems. Chapter 12 describes the various levels of survivability, but does not require any specific level. Chapter 24 requires the certain levels. In fact, the 2010 edition contains some 74 references to survivability. Now, in Chapter 12, it describes the various levels of survivability, but again, doesn't require any specific level. We have these levels 0 through 3. 0 is basically no survivability. Level 1 is a fully sprinklered building and metal raceway. That's an and. Level 2 is pathway survivability using any one of those four methods, like CI cable or an electrical circuit protective system, or rated enclosure, or a performance alternative. And then level 3 is a combination of having a fully sprinklered building plus one of the four methods. Now, this is a good example of 1 plus 2 not equaling 3. These really are three separate levels. It's not a hierarchy ranking, it's just different levels. For instance, you see that level 1 is a fully sprinklered building and metal raceway, whereas level 3 is a fully sprinklered building and one of the four methods, but has no reference at all to metal raceway. We saw the advent in the early 2000s with free air survivable cable, and we have that even down to this day. So in some cases, metal raceway may not be required as part of the survivability level. It also added this, what seemed a very benign requirement in 2010 that said you must abide by the manufacturer's instructions. Now, that seems like a no-brainer. We're used to following instructions when installing fire alarm systems, but it's incredibly important for today's CI cable listings. And this requirement is really what marries the National Fire, the NFPA 72 with the UL listing of the product. And you're going to see very clearly how that's true, but this is the requirement that marries those two things. Now, in the 2010 edition, and we go through this kind of in some detail because a lot of you may still be on 2010, but also the 2013, 16, and 19 editions are very, very closely related to what was in the 2010 edition. Most people would run off to Chapter 23, or Chapter 24, which is where our voice fire alarm systems, because that's what people think of when they think survivability, but they can miss a requirement in Chapter 23, which is the protected premises chapter. This mandates that circuits are survivable, but it doesn't designate at what level. It's basically saying for a tone-based fire alarm system, you need to provide survivability. It very much, when you ask the technical committee, they very much believe this to be a performance-based design requirement. However, many people simply go to the annex material on 23.10.2 and they see, oh, I can use one of these methods. And the very first one they come to is a fully sprinklered building. And they think, well, I'm done. Although in the annex and technically not enforceable as code, it points to a continued acceptance of allowing notification appliance circuits installed in a fully sprinklered building as meeting the intent of circuit survivability. But this really does create a conflict with Chapter 24, as we will see next. So in Chapter 24 defines that you must use pathway survivability as described back in Chapter 12, those 4 levels that we looked at. The requirements really start with EVACs, or our voice fire alarm systems, and it says very specifically if you're going to employ relocation or partial evacuation strategy in your building, like you would see in a high-rise or other zoned building, you must use a level 2 or level 3 pathway survivability. Just providing sprinklers and raceway is no longer a compliant method of survivability in and of itself. And it also makes it clear that if you're not employing relocation or partial evacuation, for instance, it's what we'd call a general alarm building, you do not have to require any survivability level. Now, many people stop right there when it comes to survivability, but Chapter 24 has much more to it. First of all, if you have an in-building mass notification system of any kind, you need to do a risk analysis to determine survivability. If you have a wide area, it's very similar. You must do a risk analysis to determine survivability requirements for that system. If you have a two-way in-building wired emergency communication system, this would be what we would call firefighter telephone. That requirement continues to be level 2 or level 3. If you have a two-way radio communications enhancement system, sometimes they're called BDAs or DAS, or they go by other names, you need a level 2 or 3 except for the antenna portion of that system. Now, it's important to note that in 2019, all of these requirements for radio enhancement systems were moved to 1221, NFPA 1221, which now has jurisdiction over those systems, and they control the survivability of their code requirements now. In fact, it's my understanding that the next edition of 1221 will include changes to the survivability requirements, or at least that's what's been proposed. If you have area of refuge, or sometimes called area of rescue assistance emergency communications, you need a level 2 or level 3, except for the off-premise communications, which is usually done by VoIP telephone or some IP or something else. But this is very important because in the last recent years, a lot of you may be doing area of refuge systems, and they've become much more robust, almost like little fire alarm communication systems in a sense. So a lot of changes have happened over the last 7 years or so for these systems. If you have elevator communications, those can be any level. It's very, very hard to provide survivable cable in an elevator travel cable, as an example. And if you have any other ECS, again, you have to do a risk analysis to determine what the survivability level is of those circuits. Now, Chapter 24 has a few further requirements regarding relocation or partial evacuation. First, similar requirements to the previous edition for all types of notification appliance circuits and protection from the control unit to the evacuation signaling zone. This term gets changed a little bit in our more current edition, but that's what it reads here in 2010. Second, we see a requirement where there's a separation of control equipment, again, like a network or a fire alarm control unit to a transponder or some other subordinate panel. If you're using distributed amplifiers, distributed NAC panels or power supplies, any of those kinds of things, again, where you have a separation of control equipment where one unit is dependent on another for action, it requires the interconnection circuits to be survivable. So those may be SLC circuits, they may be network circuits, they could even be NAC trigger circuits. All of those would fall into that requiring survivability. Additionally, if this is true, then the dependent equipment needs to be in a 2-hour fire-rated enclosure room or equivalent. So now it's not just the wiring. It doesn't make a lot of sense to send survivable wire to a piece of equipment that's not in a survivable room or enclosure or area. And this can be quite challenging to provide, certainly in some buildings. The 2013 edition made only relatively minor changes to the requirements we just discussed. Chapter 23 changed to refer only to tone-based fire alarm systems, because remember, Chapter 24 was created to do all things voice, but we had that requirement in 23 that said fire alarm systems using voice or tone. It was just a mistake. They corrected it in the 2013 edition, so now this is a very specific requirement for systems that use tone. Now we do use tone-based systems that employ relocation and partial evacuation, and a good example of that is chimes that may be used in a hospital. It may be a tone-based system, but they may be using relocation or partial evacuation as their evacuation strategy. So this would apply, and again, this is very performance-based language that says you must provide survivability, but it doesn't use any of the levels or mandate any of the levels found in Chapter 12. So this conflict between Chapter 23 and Chapter 24 basically continues. And this is also true in the 2016 edition and the 2019 edition. For the 2016 edition, Chapters 12 and 23 remain largely unchanged with regard to survivability. Chapter 24, though, makes some changes. Largely related to survivability requirements in a building that is constructed with less than 2-hour rated construction. In 2016, they added these exceptions that basically said if you're less than 2-hour fire rated, you can use a level 1 survivability instead of a level 2 or level 3. After all, it wouldn't make much sense to have the 2-hour survivable cable be the only thing left in a 1-hour rated building, for instance. And there are a lot of buildings out there that are built with 1-hour construction, such as an ambulatory healthcare occupancy that might be using relocation or partial evacuation as an example. So some relief and some alternatives were provided. Additionally, we saw that same exception provided to the firefighter telephone and that same exception provided to the area of refuge systems. Again, if you're less than that 2-hour fire rated construction as a building, then you can reduce your survivability to level 1, which again is metal raceway and a fully sprinklered building. Now for the 2016 edition, the requirement we just saw contained an exception number 2, and it talks about this 1/3 the maximum diagonal. You can use a level 1 if you have this separation between notification appliance circuits, as an example, as long as the pathway is Class X or Class N. Class X and Class N, the features of them is they're resistant to a ground fault. So this can be a little tricky to understand what this means, and some have struggled with this. In the 2019 edition, it reads this way. So instead of being an exception, they changed the manual of style, but really it says the same thing, that if you can use a Class X or Class N pathway and separate the incoming and outgoing pathways, that reduces the survivability level that you have to provide for your circuits. Let's take a look at very simple example of what this really means. So if you take a floor of a high-rise building, for instance, and let's say that high-rise building is 60 feet by 50 feet as a floor plate. You have stairs in either corner. You have an electrical or comm room next to those stairs, as an example. The separation here, that diagonal separation, is about 55 feet. The 1/3 distance calculation is the 78 feet times 1/3, which is 25.7 feet approximately. So we can place a Class X or Class N riser in each of those comm or electrical rooms, giving us a separation of approximately 55 feet. So this would meet that exception in NFPA 72, and we would not require survivable cable as long as those circuits were Class X or Class N. In a second example, we have that same high-rise building with a 60-foot by 50-foot floor plate. Again, each floor is a notification zone in this case. We calculated our diagonal at that 25.7 feet. But in this case, we have a center elevator shaft and lobby with common electrical rooms adjacent to the stairs at the center of the floor plate. Now, if we place a Class X or Class N riser in each of those common electrical rooms, it would only give us a separation of about 22 feet. So we would not meet the needed exception in 72, and thus survivable cable would be required, assuming the common electrical rooms were not 2-hour rated, although that would be an option to also meet the requirement. So you can see how this takes a bit of work to figure out, and obviously we're using a very simplified example. It's fairly easy to compute this for a square or even a round high-rise building as an example. But this calculation gets much more complicated in a healthcare, hospitality, or other more complex occupancy and floor plate. And there really is no real guidance on how this is documented or implemented, or how this can be explained to the HJ for approval. However, with the lack of guidance, gives us latitude to explain our position and document it accordingly. Now, for the 2019 edition, Chapter 12 adds the use of metal armored cable to the Level 1 definition. We've seen an increase in recent years in metal armored cable as an option instead of installing things in metal raceway. So that is now allowed at that Level 1 survivability level. Now, before we go on, we want to revisit a few important definitions. We want to understand what survivability is. We gave that at the very beginning. So that's the definition in NFPA 72. That is different than a pathway class. Pathway class is our Class A, Class B, Class C, etc. wiring. The pathway class is simply the performance characteristics of the circuit. Does it have an end-of-line resistor? Does it have a redundant path? Is it short circuit fault tolerant? That kind of thing. But they are very different. It's different than pathway survivability. Additionally is the term redundant. Redundant is simply a second, return, or alternate path. It's most closely associated with Class A, N, and X pathways. Now, redundant is often confused with survivability as if it's equal to it. A redundant path will make a circuit more reliable and may help with survivability, but it's not a replacement for it, nor does it inherently create survivability. Now, evacuation zone. Evacuation zone was used in the early editions of 72, but is not used in the 2010 edition or later. The term evacuation signaling zone or just signaling zone is now used. And this is the definition of a signaling zone. It's an area consisting of one or more notification zones where signals are actuated simultaneously. So a signaling zone can include several notification zones. So, for example, in most high-rise buildings, each single floor or fire area is a notification zone. Most emergency response plans and the building code call for the signaling zone to be the fire floor, the floor above, and the floor below. That is the signaling zone. And that's different than the notification zone, which is just an area that's served, a discrete area of a building, usually by the outer walls, but sometimes fire or smoke compartments or by floor separations. So again, notification zone is different than a signaling zone, and we got to understand that relationship. And also remember that a NAC circuit, an individual NAC circuit, should never serve more than one notification zone or smoke zone, and that is a requirement in 72. It's important to understand terms related to evacuation. So evacuation is the withdrawal of all occupants for the building. Everybody exits the building. Partial evacuation is just a partial withdrawal of the occupants, but the people do leave the building. They are instructed. So that, again, that might be those 3 floors of a high-rise building that are instructed to leave the building. But if they're instructed to go anywhere else, that's relocation. If they're instructed to go to a lower floor, if they're instructed to go to a different smoke zone or fire zone, that is relocation. So it's just important that evacuation does not include relocation. It's 2 separate terms. And it's important to understand raceway and cables. So raceway or conduit can include rigid or flexible metal conduit, electrical metallic tubing or EMT, non-metallic tubing, which is ENT, liquid-tight flexible conduit, all kinds of options for raceway. Raceway is really used to prevent mechanical damage. And that is its sole purpose. Raceway in itself does not create survivability. Now, a cable can include 2 or more conductors or wires, and it can include paired or multi-conductor cables, some with twisted or shielded components, coaxial, optical fiber, all kinds of options for cable. And the cable jacket is simply an outer protective jacket. It's just used to protect the conductors inside. And it can be made of various materials, some with temperature ratings, some with chemical protection or other. And circuit integrity cable, CI cable, is an example of using a different outer protective jacket as a way to make the cable survivable. But just a average everyday cable jacket does not make it survivable. And then finally, we talked about that cable system, or electrical circuit protective system. That's the official UL name for a cable system. And this includes the cable, the wire, the raceway, the boxes, the connections, everything. And that's the UL definition of an electrical circuit protective system. You'll see how that comes into play with product listings. Okay, deep breath. Let's talk about product listings for a moment and what effect product listings have on survivable cable. The product listing for CI cable is UL 2196. It's specific to fire resistive cables, and it's used for not just fire alarm, but all kinds of cables that might need fire resistance. But we're going to apply it specifically for fire alarm circuits. And it should be noted that this is different than the normal standards, UL 1424, for example, for the listing of cables for other types of fire alarm circuits. So it stands on its own. But this UL, let's talk a little bit more about this UL 2196 listing. The product falls in 2 categories under UL 2196. That's fire resistive cable, or FHJR, and the electric circuit integrity system, FHIT. And the way you can look at it is one's the wire and one's how you install it. That's one way of looking at it. But these 2 terms, FHJR and FHIT, become very important in a moment. The cable in the system must survive a fire test of approximately 1800 degrees for 2 hours, followed by a hose stream test, and it must still remain intact and the circuit must continue operational. And again, depending on the listing, the cable may be installed free air, or it may be placed in conduit. Now, this is what that test actually looks like. This is the UL laboratory in Northbrook, Illinois. This is a 1 foot thick concrete wall or brick wall. It's being removed from the furnace. The furnace is what heats that. In the first hour, it heats it to about 1200 degrees. And in the second hour, increases that furnace to about 1800 degrees. At the end of the 2-hour test, they roll out that wall out of the furnace, and you can see those conduits start to glow red. You can just kind of barely see that. Now, in this case, they're testing both a horizontal and a vertical installation. On the back side of this wall, you see that those are conduits. There's cabling in those conduits, survivable cable. And on the back side of the wall is basically some transformers and some light bulbs. And they are electrified, and the light bulbs have to stay lit basically to maintain the integrity of the circuit. Then at the end of the test, they have a 5-minute hose stream test. You can see that technician is going down each and every piece of conduit, spraying it with the water hose stream. Now, this is not to mimic a firefighter fighting a fire. All that's being done is the mechanical security of the actual product. It's just making sure that at the end, when it cools, especially if it cools rapidly, it's going to stay intact at the end of that 2 hours. So that's what the water hose stream test is. Very, very cool to watch. Creates a huge mess, but a lot of people have never seen this, so I thought it would be interesting to show you. Now, something changed on September 12th, 2012. UL released this statement, basically removing all listings of survivable cable from the market. Now, this placed the industry in a very difficult position. What happened to cause this? Well, according to one source, UL received information that zinc in the system or in the conduit could affect the 2-hour rating. The circuit integrity cable was compromised by the reaction of the zinc with the copper conductor. When you combine zinc and copper, it forms brass. Brass is very non-conductive. Additionally, a wide array of products, including conduits without zinc interior coating systems and cables, were not able to consistently achieve a 2-hour fire-resistive rating. Some materials can provide a carbon residue that is conductive when they heat, or conductive gases could cause permanent failure of the circuit. Thus, UL listing was rescinded, and a standards working group task group was formed to fix the situation. Well, this left many designers, contractors, and AHJs with no cost-effective way to meet the code requirements for survivability. Many struggled with how to proceed with a project that was in progress and, of course, upcoming projects. So they were forced to look at other things, like a performance-based design. Some had to make building construction changes, like the additions of 2-hour walls, soffits, enclosures, etc. Some use alternate cables or systems like mineral insulated cable or MI cable. Now, MI cable has been allowed to be used for the fire industry. You can see a picture of this. This is a fire alarm panel with MI cable being used. It looks a little like pneumatic tubing. It's a little bit difficult to work with. It can pinch and crimp, but it is allowed. What's interesting is this MI cable, it had also had its listing pulled. It was tested to the exact same standard. But new testing quickly revealed that MI products could pass the new listing under a new system, UL 1850. So a lot of the MI cable was used during that time because it quickly came back to the market, much more quickly than normal survivable cable. Well, what's the situation now? Well, several products are now listed for fire alarm circuit integrity use. There's at least 2 different major manufacturers, at least in the US, that are making these. We have both conduit and free air models that are available, but the listing has changed a little bit. The cables are listed with system components like conduit, enclosures, supports, pulling lubricant, all of that. On the data sheet, like the example that's shown here, lists the component and the specific manufacturer and model number of various things. Now, if other components are used in lieu of these, it would not meet the UL listing. So how do we figure this out? How do we know what's in a UL listing? Well, I'm going to give you a quick tutorial, and I'll go quickly through this, but basically you go to the UL website, which is ul.com, and you click on the resources tab at the top. You look for the UL Product IQ Certification Database on the right-hand side, and you click the Visit button. This UL Product IQ Certification Database allows you to log in and get these details. So you log in, or you register for free if you don't have a login. It's very easy to do. You register, and then you get inside this product database. Now, once inside the certification database, you use the search function located at the top. There's other ways to find this, but this is, I find, the fastest. And you enter that product code. Remember that product code I taught you, FHJR, for fire resistive cables, and you type that in your search feature. And that takes you to all the products that are listed under the FHJR product code. Now, again, this includes not just fire alarm, but all types of fire resistive cables. Now, we see a lot of information, and let me kind of break this down for you. First, we see a link that gives you general information about FHJR cables, and that can be good information to understand and to review. We'll look at that again in a few minutes. Next, we have all the listed companies that have listed cables. So nVent, Marman, Prisman, Radax, Comtran, all of the manufacturers that have the listed cables. The R number, so you see like R21213, that is known as the company's file number. And we'll click on that in a minute to show you what's underneath that. And last, we see a list of related listings that may provide more information. In our case, about non-fire rated fire alarm communication circuit cable, and also general information about the FHIT category, which we'll show you in just a few minutes. Now, from here, you can click on the link to a file. In this case, we're going to click on the Radax one because they're well known in the industry, just as an example. Once inside that company's file number, you find a chart that looks like this. The listing file shows the brand name of the cable. You see that there in these listings down the edge. You also see the hour rating of the cable. In this case, it's a 2-hour rated cable. You see the test that was used, the 2196 test that we just saw on the video. It shows you the number of conductors that's inside that cable. It shows you the wire gauge or available wire gauges of the cable, in this case 16 and 14 gauge, and the maximum voltage rating that the cables were tested to. In this case, a line-to-line voltage of 72 volts and a line-to-ground of 42 volts. Now, obviously, most of our circuits are going to be in the 24-volt range, certainly less than 30 most of the time, but that at least tells you what they've been rated to. It also tells you what system it must be installed with. And note, it says specifically when installed in accordance with the manufacturer's installation instructions, and it even gives a date of those instructions. Finally, you look for the FHIT number. It could be just the 28A, like you see in the lower example, or it could actually be FHIT.40 in another example. So some differences, but that's what you want to look for, is the system number or the FHIT number that's located based on the company's listing. It means the same thing, but the blue text is also a link on the website. So we're going to click on that, and it brings you to a page like this. It's the FHIT listing table, usually with US and Canadian options, as you see in this example. It lists out all the manufacturers involved with the installation of this UL cable. So click on your selection. In this case, we want to use the US FHIT number. Now, this provides detail on the installation, again, including specific manufacturer information on raceway, supports, lubricant, etc. It includes details on how to mount the cable selected in various ways or in various configurations. Now, theoretically, these details should be included on installation design documents and shop drawings as appropriate. Now, when you go through all the detailed information, I'm going to quickly go through this. Item 1 details that this installation can penetrate both wall and floor assemblies, proper fire stopping must be used, etc. Section 2 highlights what raceway can be used for the installation. In this case, just 2 manufacturers can be used, Allied Tube and Conduit and a Wheatland or Western Tube. Those are the only 2 types of conduit that can be used. You can't just go down to Home Depot and pick up a piece of conduit off the rack. It also details for this cable that when using a 2-conductor cable based on wire gauge, the number of cables that can be installed in what size conduit. So in this case, the 14 gauge cable, you can have 4 cables in a 1.5 inch conduit. So in this case, you're not following the NEC fill chart. That does not apply. You need to you can only do this as it's stipulated in this chart. Now, often notes appear at the bottom of this section to state what rules must apply, and you can take a look at those. There are usually additional sections that indicate what raceway couplings must be used, in this case 2 couplings and similar type requirements. Section 3 provides information on the cable itself, including the need to follow manufacturer's instructions. This also includes 2 important details. It says the cable should pass completely through the fire zone and terminate a minimum of 12 inches beyond the fire rated wall. And 2, the cable can be installed horizontally or vertically or both. Sections 4 and 5 have further instructions showing what type of supports and clamps may be required, how far apart those clamps would be. Hopefully by now you're having so much fun you've glazed over and passed out, but it's all in there. It also has references to figures, which were the figures we showed before. Again, a lot of the specific installation instructions that should be included in a shop drawing. Section 6 details what to do when splices are involved. This usually involves both specific boxes and compression fittings, as well as a specific procedure that's detailed in the manufacturer's instructions. Section 7 dictates the pull boxes that must be used and how they're installed. Section 8 details the only type of pulling lubricant that can be used. You can't, again, just use any pulling lubricant. And this UL product file may contain more or somewhat less information for your specific type of manufacturer, but the above is typical of what can be found under that FHIT listing page. Now, I do want to point out that UL provides a usage disclaimer on their website for these installation instructions, and they usually look something like this. First, the installer is pointed to the AHJ for quote-unquote particular requirements, unquote, of installation and shall be consulted before construction. And second, the published information cannot address every construction nuance. You have to call the manufacturer and not call UL, is what these say. The general FHJR information includes general information on the testing used, the use of installation, product identity, related products, and similar type information. And the general FHIT information provides, again, general information on the testing used, use in installation, related products. It does include the specific requirement that electrical circuit integrity systems are intended to be fastened to a concrete or masonry wall or concrete floor and ceiling assemblies, which is a whole nother topic that we're not going to get into today. And so we get this product listing that has this complete system that must be installed to exacting standards, and that's where this gets to be very, very difficult. So what fire alarm circuits must be survivable and how can this be accomplished? We've talked about a lot of code requirements so far, but let's see, let's break it down to what we specifically need to know. Now, for a proper fire alarm design, you need to answer several basic but important questions. What circuits need survivability? Certainly not all circuits require survivability, but if you don't think this through, you could miss some, thinking only that, for instance, a notification appliance circuit is what applies. That would be a mistake. Where do these circuits need survivable components? Now, again, just because a circuit needs to be survivable does not mean it needs to be survivable everywhere or end to end. How will survivability be achieved? So what method can we use to achieve survivability? Will we use CI cable? Will we use a cable system? Will it be vertical or horizontal? Will it be free air or in conduit? All of that needs to be answered. However, before we review each of those components, what must we know? We must first know the details of the emergency plan of the building. Now, I know all of you, when you bid your projects, they hand you the drawings and they hand you the emergency response plan for the building. So you know all of this, right? Well, that can be very, obviously that's not happening in a normal course of events. We have to know what the evacuation scheme is. Is it a general alarm building? Because if it is, then we're done from a survivability standpoint. However, if we assume it's a general alarm building and it turns out not to be, then we're in for some very expensive rework, change orders, and probably liquidated damages. Are they planning for selective floor evacuation as we see in a typical high-rise scenario? Is this going to be a relocation or partial evacuation scenario as we see in, let's say, a healthcare occupancy or a hospital occupancy? Are there other selective signaling needs that need to be achieved, like two or three channel audio or evacuation messages playing in one place and stay in place orders in another? It would also be good at this point to see what other types of systems in the building, like an area of refuge system or a firefighter telephone or other systems, what are they planning? How are they going to meet survivability in the building? You may only be responsible for the fire alarm system, but if multiple systems need survivability, there may be joint solutions that are possible, and often this can be discussed with the electrical contractor or architect. Now, if survivable cable is needed, you need a complete copy of the architectural drawings. You must be able to read and understand the architectural wall and floor ratings, especially for the ratings of the electrical or communication rooms. Often these rooms are stacked in a high-rise and are required by other building codes to be 1 hour, 2 hour, or other such rating. Many times, survivable cable can be avoided completely or used very sparingly due to being able to use these stacking rated rooms for risers and circuit origination. Now, you also need the smoke zone boundary drawings, especially in healthcare occupancies. Based on the boundary locations and electrical room locations, the locations for survivable cable runs can be identified prior to bidding in order to properly capture installation costs. So now back to the 3 questions we need to answer. First, what circuits need survivability? Well, very first and foremost, all types of notification appliance circuits. Now that includes loudspeaker circuits, that includes audible tone circuits like chimes or horns if we're using relocation or partial evacuation, and visual circuits, so strobes, textual appliances, anything else that we might be using. Any notification appliance is going to need some survivability if we're using that relocation or partial evacuation. Network circuits, which is usually RS-485 or remote unit communication, which might be RS-232, like for remote amplifiers, transponders, other subordinate panels. We usually require survivability because these circuits trigger notification in remote areas. And again, we have to remember that key word is dependent. What happens when the connection between those two things is interrupted? And if we cannot still trigger that emergency message, then that needs to be survivable. Now, what happens if you desire or need to use optical fiber to connect network panels and you need survivability? Now, this is often done. We like the advantages of optical fiber. Well, is there a 2-hour fire-rated fiber optic cable? And the answer is no, there's not. But there is a 3-hour fire-rated optic cable because that just makes sense in the world we're living in, doesn't it? This is a 3-hour fire-rated cable. I just put a little information. The downside is that this is listed to an IEC standard and not the UL 2196 standard. It cannot withstand the water hose stream test. So it can survive the furnace for 3 hours, but it can't survive that water hose stream test at the end. Now, is it possible that you could make a viable argument for the use of this cable? Yes, you would just have to make that argument to the AHJ and try to get it approved. And I know of some installations that have gotten this cable approved for installation. It is quite expensive. What other types of circuits? Well, signaling line circuits. When signaling line circuits are used to control remote NAC power supplies, or when used to control modules like relay modules that trigger NACs or amplifiers, then that SLC becomes a control circuit and needs to be survivable. And again, remember Chapter 23 regarding SLC zoning, that it requires each floor to be a separate zone. And if a floor is subdivided into multiple zones by fire and smoke zone or relocation, each zone shall be considered a separate zone. So this can get a little taxing, a little complicated. Now, there may be other types of circuits that need consideration. Perhaps you have an audio riser circuit or dual or multiple channel audio that's distributed in the building. That's going to need survivability. Again, we mentioned firefighter telephone is going to require some form of survivability, either level 2 or level 3. And also, what about 24-volt power? Well, normally we would not have survivability on these, but perhaps if sounder bases are used in the evacuation sequence and you must run power through a different zone to get to the devices, then a power circuit becomes a de facto NAC in that sense. So we've got to think through some of these things just a little bit. Now, there may also be other types of circuits that need consideration that are not specifically required by NFPA 72 because this hasn't been fun enough already, right? An example here is from the 2018 edition of the IBC, and it's the same as the 2015 requirements. All smoke control system control wiring, that's fire alarm, shall be in continuous raceway. This is for mechanical protection and does not provide survivability. This might negate the use of 2-hour free air rated cabling. Then for smoke-proof enclosures, which is our stairs and our hoistways, Section 909.20.6 gives you 3 options for control wiring. Wiring located on the exterior of the building, which is probably not going to happen. A wiring located within the 2-hour rated smoke-proof enclosure, which in most cases does not occur. And wiring located in a building but separated by a 2-hour barrier or assembly, and that's usually the one that is selected. And you can see in the requirement, it's referring to the UL 2196 rating, so it's talking about survivable cable. Now, the second question we needed to answer, where do these circuits need survivable components? And remember the code requirement from NFPA 72, Chapter 24. It says survivable from the FACU until they enter the notification zone. Now, there's a little room for question here. How far into the notification zone? What if it passes in and out of 2-hour enclosures between the 2 points? Must you go to the first device, to a terminal cabinet, to a J-box, another control unit? In this case, it just means what it means. As to how far, I suggest at least 12 inches into or beyond the fire-rated wall. I take this obviously from that UL documentation where it requires the distance of 12 inches, although NFPA 72 itself is silent on the matter. Now, for circuits feeding remote panels like network or audio riser, SLC connections to power supplies, etc., I suggest continuing the survivable cable or conduit all the way to the remote panel. So in this case, from the fire alarm control unit up to that remote panel, that would all be in CI cable. Now, in reality, there's nothing wrong with terminating the survivable cable after entering the notification zone, transitioning to normal cable, and continuing to the control unit. If this requires a large amount of survivable cable, then that might be appropriate due to the expense. But if there's just a short distance to go, you're better served by continuing the survivable cable without an additional termination, which becomes a possible failure point in the future. Now, once inside the notification zone, you can transition from survivable cable to normal cable as required for the situation using FPL, FPLR, FPLP, whatever the appropriate type of fire alarm cable would be. Now, it's suggested you do this using a properly sized junction box like the one shown here, or terminal cabinet, even better. That provides the survivable cables is harder to deal with than normal cables, so it's very advantageous to have a terminal cabinet. Also, some free wire cable in particular is listed with specific types of wire nuts. In this case, those are ceramic wire nuts that you see. They have no metal, but that's what they're listed for, and so you would have to follow the product listing of the free air cable if that's indeed what you're using. And then, of course, you have to remember all your through penetrations have to be fire stopped when passing through fire rated floors and walls. And even though that's not normally your job as a fire alarm installer, you need to be aware of it. Our last question is, how will survivability be achieved? Will you use or decide to use CI cable? And if so, will you need a conduit system, or can you run it in free air? And our next suggestion will give you a few design considerations along those lines. So here you can see we're using a 2-hour rated cable from the fire alarm control unit up into the notification zone, so that cable between the control unit and, let's say, the first device, or at least into the zone, would be 2-hour rated cable. And then once you're on the floor, you're using the normal fire alarm cable in that installation. Now, are you able to take advantage of the building's construction by using stackable 2-hour rooms? It's a better option to build 2-hour enclosure. Is it a better option to build 2-hour enclosures? Here you see, if we run from the fire alarm control unit into a 2-hour enclosure up to the notification zone, none of that wiring would need to be survivable because you're staying in the 2-hour enclosure until you get into that zone. So the building construction can provide you every possibility as long as you have those, you're aware of the ratings and you know what you can use, but can save a lot of cost on a fire alarm installation. And it might be possible to meet with the AHJ and provide some other equivalent means that's acceptable to them. All right, let's do our last section, and I promise we'll only run a couple of minutes over. How do we do a design and get AHJ approval of a survivable circuit? First and foremost, know the code. Understand the key definitions, including pathway survivability, pathway class, signaling zone, and notification zone, as we discussed earlier. If the building is general alarm now, will it always remain that way? Chapter 12 contains your pathway survivability levels, but does not dictate which ones must be used. Chapter 23 requires that any fire alarm system using partial evacuation or relocation needs to be survivable. Don't get fooled into thinking that just because a building is fully sprinklered, you do not need to provide survivable cable. Chapter 24 contains the specific requirements, the when of survivability levels must be provided. Now think about all types of circuits, not just notification circuits, but think of that word dependent and what must be provided. What is dependent on something else, and what happens if that dependency is severed? Second, know your system. Each fire alarm system is unique, and you all know that. Various systems have different approaches to system infrastructure. Some use centralized amplifiers and power supplies. Others use more decentralized equipment. There's different networking communication schemes. There's peer-to-peer, there's master-subordinate. You have to know what you're being used and how you're triggering. You have to understand the programming requirements for selective signaling, so you know what things are being turned on and when. And you have to know your NAC control options and capacity. Obviously, that's easy. And in the case of Autocall, you've got SLC triggered NAC panels. It's a great advantage, but you got to know that. And you got to know that now that SLC may require some form of survivability depending on where it's run. You also have to understand the effect survivable cable may have on your system's calculations. Normal voltage drop uses industry standard resistance figures when calculating voltage drop. But survivable cable has unique cable resistance. So in this case, rather than the standard of 1.93 ohms per 1,000 feet, the CI cable actually has a lower resistance. It's only 1.618 ohms per 1,000 feet. So in this case, that's advantageous to you, but is that true in every case? So again, it's one more thing you have to check when using your CI cable. Third, you must understand your available options. What advantages can the building construction provide for you? And the answer is every advantage. If you have stackable 2-hour electric rooms, this may negate any requirement for survivability or limit survivable cable to smaller horizontal runs rather than large vertical runs. Speaking of that, how long are your survivable cable or cable system runs? This will vary greatly depending on your fire alarm control unit infrastructure. Can you make changes to the fire alarm unit layout to make better or limited use of survivable cable? Depending on the length of the vertical run, you may require extra installation requirements. So in this case, what you see on the screen there is a vertical installation of survivable cable, and because this survivable cable is running over 30 feet, it has to be supported with that cable strain or cable support. That's all listed with the device, and you have to install it in that way, or else it would not meet the UL requirements. Also, will cable splices be required? You do not want to have to splice survivable cable in the field. You got to trust me on that. But you need to know the very unique requirements there. Is free air cable an option? And sometimes it is, but note that the support spacing may be quite a bit different than what you're used to. Sometimes it's as little as every 24 inches has to be supported, and with a specific type of hanger. So you've got to look at those requirements. And is a performance-based alternative your best option? And if so, how will you document that to the AHJ? And who's going to bear the cost of survivable cable? Is it the fire alarm vendor? Is it the installer? Is it someone else? You need to figure out, because survivable cable is quite expensive. Fourth, we want to explain thoroughly our design. Once you decide your course of action, you want to be able to communicate with the installing contractor the exact type of conduit and installation requirement. What needs to be shown on the floor plan? You often need a unique line type or call out and dimensions. You need a riser diagram that shows leaving the FACU to the zone or floor of destination. What installation diagrams are necessary? Vertical supports, horizontal supports, fire stopping, etc. And what calculations are necessary? Do you have to modify your voltage drop, your conduit fill requirement, your confirmation of wire gauge, etc.? Ultimately, your quality design can assist in the timely approval of shop drawings and the proper review and approval of the AHJ during acceptance testing. Now, as a designer and vendor, it's important for you to inspect the installation for compliance with the design requirements. Was the proper cable system, conduit, and supports provided, and does it match the manufacturer's UL approved instructions? Was proper fire stopping provided? Again, that might not be your job, but you have to double check it that their installation has met your design. And we want to help the AHJ to understand. The AHJ sees all variety of different systems and layouts and may not be overly familiar with your particular brand of fire alarm system. So fully explain your system's infrastructure. Are you using one central FACU and distributed or remote equipment? How does that system communicate? What are the system's dependencies? What happens if you lose a connection? What will work and what will not? Show that you have met the intent of survivability in the code. Clearly explain the evacuation sequence, whether selective floors, relocation, or partial evacuation is being used. This is especially true if relocation is being used with private mode signaling, like in hospitals. Keep in mind that your AHJ may review very few, if any, building designs that require survivability. Thus, by providing installation details that can be reviewed on review and acceptance testing, you can assist him or her to understand the system and ultimately approve the system. So you have just survived survivability. I think I have just survived the presentation. You can survive this, but it takes knowledge, effort, and a real focus on the details. And so I provide that to you. Hopefully it was helpful. And my contact information is there. Again, you'll get a copy of the PDF handout if you would like it by contacting Anne-Marie. And Anne, I'll turn it back over to you for any. I know we ran late, so I'll leave it up to you how you want to do that.
Great, thank you, Larry. Again, lots of great information as usual. So we are very grateful to you for that. I do have one question that was posed, and it says, can you T-tap CI cable? So it's kind of a multi-part question. Can CI cable be landed on a panel while maintaining the CI listing if it's not in a 2-hour rated room? And then are there terminal cabinets that are rated for 2 hours that can be utilized for CI cable splices?
All good questions. Let me take the first one about the T-tapping. Yes, you can. If the circuit allows a T-tap, so in the case of like your SLC, you allow T-taps. If the circuit allows a T-tap, you can T-tap CI cable, but you should do that at a terminal block or at minimum a junction box. But a terminal block would be a much better way to do it. But yes, you can terminate it. It's really just like any other circuit, as long as you're following the rules of that circuit.
Okay. Do you want me to read the second one again, Larry?
I do.
Okay. Can CI cable be landed on a panel while maintaining the CI listing if it is not in a 2-hour rated room?
Technically, no. If it's not in a rated room, and it should be, the control equipment should be, then technically just connecting CI cable to that control panel would not meet the intent of the UL listing. Now, sometimes that is done. You also might have, if once you're in the zone, Again, you can transition to normal cable and go to normal cable to, let's say, a control panel that's not in a rated room and then land that. But again, you got to look at these scenarios. It's kind of based on the specific scenario. But letter of the law, per the question, the answer would be no.
Okay, and the final piece of that was, are there terminal cabinets that are rated for 2 hours that can be utilized?
That's a great question. I'm going to answer it in kind of a cheater way. There are terminal cabinets and junction boxes that are provided by the manufacturers of survivable cable that should be used with the survivable cable installation. I do not believe those terminal boxes or junction boxes in and of themselves carry a 2-hour rating. I could be wrong about that, but to my knowledge, that does not exist. Now, you can get 2-hour rated enclosures, just like you would have a 2-hour rated access panel for a shaft, as an example. So you can get that on the market, but again, you want to use the junction boxes that are listed with the survivable cable where you can, and then if you're having to do it outside, you're going to have to look at alternate ways to meet that requirement.
Great, thank you. That is the only questions that were submitted online. I will pause a moment here if anyone would like to unmute themselves and ask a question. Now's your chance.
No takers today, I guess.
No takers. As Larry said, we will obviously be making this recording available as we have with all of them, and the recording will be on the Autocall site in the dealer section, so you do need to be logged on in order to be able to access it. But also, if you would like copies of things, the print materials or handouts, whatever, please email me, or you can contact your area sales manager, as I will be sending everything along to them as well. And again, we thank everyone for joining us and hope you have a great day.
Thanks, everyone. Have a great day.
Thank you.